Good morning. Today we have to start one more point, that is interference of light. Interference of light. Today we have to see one more point, that is about interference of light. See, suppose this one as one wave travels along positive direction of x-axis like this. This one as one another wave like this. This one as one another wave like this. Both waves are along same direction. Means vibrations of both waves are along same direction. Therefore, such waves are called as in phase or in same phase. Take one more example. Suppose this one as one wave like this travels along positive direction of x-axis, and suppose this one as one another wave like this. Direction of vibrations are in opposite direction. In this case, direction of vibrations are along same direction, called as in phase. And if directions of vibrations are opposite direction, then such waves are out of phase. Out of phase. In phase means same direction of vibration. Out of phase means opposite direction of vibration. If waves are in phase, then they interfere with each other, and the resultant wave is like this. Means resultant displacement of these two waves is factor sum of displacements of these two waves. In this case, resultant opposite direction, resultant, that is difference between magnitude, and therefore resultant is like this. Means if waves are in phase, then resultant intensity increases. In case of out of waves, resultant intensity decreases. Means there is modification of intensity of light. इंटेन्सिटीचं मॉडिफिकेशन होतं, म्हणजेच एकतर इंटेन्सिटी इन्क्रीज होते किंवा इंटेन्सिटी डिक्रीज होते. द मॉडिफिकेशन ऑफ intensity of light. The modification in the intensity of light produced due to superposition of two or more light waves. The modification in the intensity of light. लाईटच्या इंटेन्सिटीचं मॉडिफिकेशन होतं. ड्यू टू सुपरपोजिशन ऑफ two or more light waves is called as interference of light. What is interference of light? The modification of intensity of light due to superposition of two or more light waves is called as interference of light. Means when two or more light waves travels through a medium, then resultant intensity increases or decreases. If light waves are in phase, then resultant intensity increases. If light waves are out of phase, then resultant intensity decreases. This modification of intensity of light produced due to superposition of two or more light waves is called as interference of light. There are two types of interferences that are constructive interference and one more, that is destructive interference. There are two types of interferences that are constructive interference and destructive interference. If suppose two waves are equal in wavelength and amplitude. समजा ही ताशी दुसरी वेव आहे, दोघांची वेवलेंथ amplitude equal आहे, equal in wavelengths and amplitudes are in phase, then resultant intensity at that point is maximum, like this. Such an interference is called as constructive interference. Means in this interference, resultant intensity is sum of intensities of these two waves. This is called as constructive interference. In this case, crest due to one wave is coincided with crest due to other, and trough due to one wave is coincided with trough due to other. In this case, like this. Suppose this one as one wave, like this. This one as another wave having equal amplitude and wavelengths. Having equal amplitude and wavelengths traverse through medium. Then resultant intensity at that point is 0 or minimum. In this case, resultant intensity is maximum. In this case, resultant intensity is 0 or minimum. Waves are out of phase. Such an interference is called as destructive interference. In this case, crest due to one wave is coincided with trough due to other, or trough due to one wave is coincided with crest due to other. See, there are two types of interferences that are constructive interference and destructive interference. What is constructive interference? If two waves having equal wavelength and amplitudes, when two waves having equal wavelength and amplitudes traverse through medium are in phase, then resultant intensity at that point is maximum. In this case, crest due to one wave is coincided with crest due to other, and trough due to one wave is coincided with trough due to other. Such an interference is called as constructive interference, and corresponding point is bright. In this case, destructive interference. When two waves having equal wavelengths and amplitudes, when two waves having equal wavelength and amplitudes are traversed through a medium are out of phase, then resultant intensity at that point is minimum or 0. In this case, crest due to one wave is coincided trough due to other, or trough due to one wave is coincided crest due to other. Such an interference is called as destructive interference. Resultant intensity is 0 and therefore corresponding point is dark. If resultant intensity is maximum, then corresponding point is bright. And if resultant intensity is 0 or minimum, then corresponding point is dark. In this constructive interference, phase difference between two waves is either 0, 2 pi, 4 pi, 6 pi, like this. That is path difference between them. Path difference between them is either 0, lambda, 2 lambda, 3 lambda, which is equal to n lambda. Means if path difference between two arriving waves is equal to integral multiple of wavelength, then corresponding point is bright. This condition is called as condition of brightness. What is condition of brightness? That is path difference between two arriving waves is integral multiple of wavelength lambda. In this case, phase difference between them is pi, 3 pi, 5 pi, like this. That is path difference between them. Path difference between them is lambda by 2, 3 lambda by 2, 5 lambda by 2, which is equal to 2n minus 1 lambda by 2. How odd number है? Means path difference between them is odd integral multiple of half the wavelength lambda. Here path difference is integral multiple of wavelength. Here path difference is odd integral multiple of half the wavelength lambda. हा या दोघातला डिफरन्स आहे. These are conditions of brightness and darkness. Means for constructive interference, resultant intensity is maximum and corresponding point is bright. Path difference between two arriving waves is integral multiple of wavelength. For destructive interference, resultant intensity is minimum or 0, and path difference is odd integral multiple of half the wavelength lambda, then corresponding point is dark. Thus, there are two types of interferences, that are constructive interference and destructive interference. Okay. म्हणजे आतापर्यंत आपण काय पाहिलं? About interference of light. What is interference of light? The modification of intensity of light. The modification of intensity of light produced due to superposition of two or more light waves is called as interference of light. There are two types of interferences, that are constructive interference and destructive interference. Okay. Now, conditions for well defined steady interference pattern. म्हणजेच एखादा इंटरफरन्स पॅटर्न हा वेल डिफाइंड आणि स्टेडी असण्याच्या कंडिशन्स, जो इंटरफरन्स पॅटर्न तयार होतो हा इंटरफरन्स पॅटर्न वेल डिफाइंड आणि स्टेडी असण्याच्या काही कंडिशन्स आहेत. फर्स्ट, two sources of light must be coherent. coherent. The two sources of light must be coherent. That is, phase difference between them is either 0 or constant. If phase difference between two arriving waves is 0 or constant, then corresponding sources are called as coherent sources. What are coherent sources? The sources which produces waves having a phase difference between them is either 0 or constant, and having same frequency. हा एक शब्द वापरायचा बघा. What are coherent sources? The sources which produces waves having same frequency and having a phase difference between them is either 0 or constant. Such as sources are called as coherent sources. पहिली condition, two sources of light must be coherent. Second, two sources of light must be monochromatic. That is, these sources produces waves having equal wavelengths. These sources produces waves having equal wavelengths because position, width and color of fringes depends upon wavelength. Because position, width and color of fringes depends upon wavelength of wave, and hence the two sources of light must be monochromatic. Third one important, two sources of light must be equally bright. That is, these sources produces waves having equal amplitudes. Because intensity of resultant wave depends only upon amplitude of wave. If amplitudes are not equal, then intensity of dark fringe is not 0 and contrast between bright and dark fringes is maximum, and hence two sources of light must be equally bright. ह्या तीन कंडिशन्स फार महत्वाच्या आहेत. खरं तर आणखी पण काही कंडिशन्स आहेत, पण ह्या तर तीन कंडिशन्स फार महत्वाच्या आहेत. कंडिशन्स फॉर वेल डिफाइन्ड स्टेडी इंटरफरन्स पॅटर्न. फर्स्ट, two sources of light must be coherent. That is, these sources produces waves having same frequency and phase difference between them is either 0 or constant. Two sources of light must be monochromatic. That is, these sources produces waves having equal wavelengths because position, width and color of fringe depends upon wavelength. One more, that is, two sources of light must be equally bright. That is, these sources produces waves having equal amplitudes because intensity of light is directly proportional to square of amplitude of wave. Intensity depends upon square of amplitude. Only if amplitudes are equal, intensity of dark fringe is 0. If amplitudes of two waves are equal, then intensity of dark fringe is 0. Otherwise, intensity is less bright. Intensity of bright point is maximum, no doubt. But intensity of dark band is not 0 and corresponding point is less bright. one more condition. Two sources of light must be narrow. Two sources of light must be narrow. If slits are broad, distances from different points along the slit to the given point on screen are different, and hence blurred interference, blurred, B-L-U-R-R-E-D, blurred interference pattern is produced. The two sources of light must be narrow. If sources are broad, then distances from different points, these are different points on sources, then distances from different points to the along slit to the given point on screen are different, and hence blurred interference pattern is observed. Fifth one, that is separation between slits. Separation between slits must be small as comparatively distance between slit and screen. Means distance between two sources are very small, is very small as comparatively distance between sources and screen. दोन सोर्सेस मध्ये डिस्टन्स स्मॉल पाहिजे, सोर्सेस आणि स्क्रीन यांच्यामधलं डिस्टन्स मात्र लार्ज पाहिजे. सेपरेशन बिटवीन टू स्लिट्स मस्ट बी स्मॉल ॲज कम्पॅरेटिव्हली डिस्टन्स बिटवीन सोर्सेस अँड स्क्रीन. अँड वन मोर कंडिशन, द टू इंटरफेरिंग वेव्स मस्ट बी इन द सेम स्टेट ऑफ पोलरायझेशन. सेम state of polarization. The two sources of light must produce waves having same state of polarization. These are some conditions of steady and well defined interference pattern. 6 conditions आहेत. कोणते 4 तर लक्षात ठेवा. एक सेंटेन्स लक्षात ठेवलं तरी चालेल. द टू सोर्सेस ऑफ लाईट मस्ट बी कोहरंट. टू सोर्सेस ऑफ लाईट मस्ट बी मोनोक्रोमॅटिक. टू सोर्सेस ऑफ लाईट मस्ट बी इक्वली ब्राईट. द सोर्सेस मस्ट बी नॅरो. सेपरेशन बिटवीन स्लिट्स इज व्हेरी स्मॉल ॲज कम्पॅरेटिव्हली डिस्टन्स बिटवीन स्लिट अँड बोथ सोर्सेस मस्ट प्रोड्यूस वेव्स हॅव्हिंग सेम स्टेट ऑफ पोलरायझेशन. Okay, these are some conditions of well defined and steady interference pattern. Now, next point about coherent sources. आताच आपण इथं पाहिलं पहा about coherent sources. COHERENT, coherent sources. What are coherent sources? The sources which produces waves having same frequency and having a phase difference between them is either zero or constant, independent of time. The sources which produces waves having same frequency and having a phase difference between them is either zero or constant, independent of time. Such sources are called as coherent sources. What are coherent sources? The sources which produces waves of same frequency and phase difference between them is either zero or constant independent of time are called as coherent sources. Methods for obtaining coherent sources. Methods for obtaining coherent sources. Coherent sources. There are different methods for obtaining coherent sources. What are coherent sources? The sources which produces waves of same frequency and a phase difference between them is either zero or constant independent of time are called as coherent sources. Methods for obtaining coherent sources. 1. Young's double slit experiment, YOUNGS. Double slit experiment. Second one, that is Fresnel biprism experiment, FRESNEL. Biprism experiment. Then Lloyd's mirror. Third one, Lloyd's, LOYDS, Lloyd's mirror. Methods for obtaining coherent sources. First, Young's double slit experiment, Fresnel biprism experiment, and Lloyd's mirror. First of which, Young's double slit experiment. In this experiment, two coherent sources are obtained by making light from single source. Suppose this one as a single source, yes. Then a slit having two pinholes is kept in front of slit. Then these two pinholes are at same distance from this source, and this produces waves. That waves are in phase. Changes produces in main source produces same changes in both sources, and therefore phase difference between them is either zero or constant. Such sources are called as coherent sources. म्हणजेच एका सोर्स पासून आपण असे दोन सोर्स बनवतोय. एका सोर्स पासून असे दोन सोर्स बनवतोय. इथं जो काय चेंज होईल तो चेंज दोन्ही सोर्स मध्ये सारख्याच पद्धतीने होत असतो. म्हणजे त्यांच्यातला फेज डिफरन्स झिरो राहतो. और आयदर जो काय चेंज असेल तो कॉन्स्टंट राहतो. Therefore, these two sources acts as coherent sources. In this experiment, two coherent sources are obtained by making a light from single source and pass through two narrow slits. In this case, two coherent sources are obtained by making a light from single source and then pass through two narrow slits. Fresnel biprism experiment. In this experiment, two coherent sources, suppose this one as biprism, this one as a single source, like this. In this case, incident rays are like this. Incident rays are like this. After refraction through biprism, these rays travels along these directions like this. These refracted rays are appears to come from, suppose, S1. These two refracted rays appears to come from, suppose, this point S2. Suppose this one as our main source. Incident light, incident rays from source S after refracting through biprism appears to come from S source. After refraction appears to come from S1 and S2, acts as two coherent sources. In this experiment, coherent sources are obtained by using biprism. Biprism consists of two right-angled prisms of refracting angles 1 degree each, connected base to base, so that angle of refraction of biprism is 178 degree. This is called as biprism. What is biprism? Biprism consists of two thin right-angled biprisms. Biprism consists of two thin right-angled prisms having refracting angles of 1 degree each, connected base to base, so that refracting angle of biprism is 178. This biprism is kept in front of source, and screen is kept at some distance from this biprism. Incident rays from source S. Incident rays from source S after refracting through biprism. म्हणजे हे दोन रिफ्रॅक्टेड रेज या पॉइंट मधून आल्याचा भास होतो आणि हे दोन रिफ्रॅक्टेड रे या पॉइंट मधून आल्याचा भास होतो. मीन्स रिफ्रॅक्टेड रेज आफ्टर रिफ्रॅक्शन appears to come from S1 and S2, acts as coherent sources. Okay. And third one, Lloyd's mirror. In this case, suppose this one as Lloyd's mirror like this. Suppose this one as Lloyd's mirror. Light from source S. Suppose this one as source S. Light from source S is made to fall at a grazing angle on plane mirror. Light from source S. Light from source S like this. Light from source S is made to fall at grazing angle, GRAZING, grazing angle. In this case, light from S is made to fall at grazing angle on plane mirror. Some of light falls directly. Some of light falls directly on screen, and some of light falls after reflection. Some of light falls directly on mirror, and some of light falls after reflection. The reflected light appears to come from two virtual sources. The reflected light like this, reflected light appears to come from two different sources. These two sources act as coherent sources. Some of light falls directly on screen and some of light falls after reflection. The reflected light appears to come from two virtual sources, acts as coherent sources. These are different methods for obtaining coherent sources. Young's double slit experiment, Fresnel biprism experiment, and Lord's mirror. Okay. Now, remaining part on next period.